Now, before we do, though, I'm going to give you a quick pop quiz. Fair enough? All right. So what I'm going to do is I'm going to give you about 10 seconds to memorize everything on these cards. Fair enough? All right.
I don't realize if I'm going to see you.
This one's not too bad. All right. So I'll give you about 10 seconds.
I can't see it anyway.
Can't see them? I'll get a little closer.
I couldn't see them if you had them here.
No? Yeah, so, okay, yeah, so
They're all blank.
it appears there's nothing there, right?
Yeah.
All right, so I'll give you quiz questions then. First off, how many cards were there?
5.
5, okay, there were definitely 5 cards. Excellent. Now the next thing is, what's on the face of the cards?
Nothing.
Well, yeah, I mean, it turns out that you might have missed the ace. I mean, there's an ace in there. That's a pretty good card, but it's kind of a small pip, so I understand. You know, it's pretty easy to mix it up. What color was the back of the cards?
Red.
Yeah. Turns out they're all red, right? So, next thing is, besides the ace, what were the rest of my cards?
They were blank.
Yeah, it looks like a royal flush, right? So if you're playing poker, you got to be a little more careful, right? So this is the same type of thing in CSI. We may have like our initial suspicions of what something is, but when it boils down to it, we have to look at the evidence, right? We have to dig a little deeper, and then sometimes we have to be willing to, change our opinions. Oh, and I think I was talking too long. See if I can fix that.
That's what I was looking for.
There we go. All right. So, when we're talking about CSI, the television show, the original CSI aired in the year 2000, actually just ended its last episode last October. So, I mean, that's a pretty good run for a television show. And it's not just here in the US. I mean, there are about 74 million viewers a year watching this around the world. That's pretty impressive. It was named the best television drama series 3 different times, which, again, notice the word drama, right? So are these episodes, is this really how it works?
No.
Not so much, right? It turns out that about 50% of what you see on CSI type shows is just completely fabricated, right? No basis in reality. The other 50% is real, but they typically speed it up, make it a little more exciting and so forth. So we're going to talk about what's real, what's fake, and why it matters. Well, one reason that it matters is because people watch these, right? Not only CSI, but all of the various shows that are out there. Everything from, the spin-offs of CSI to Bones. A lot of people are big fans of Bones. Some are a little more realistic than others. But it turns out that because these shows are so popular, the legal system has actually coined a new term called the CSI effect. What this is there are several ramifications. One is that jurors expect more evidence, right? They want physical, hard evidence. They don't just want eyewitness testimony. They want DNA, right? They want fingerprints. They want all of these things. And when that evidence isn't present, then they tend to acquit people more often. In fact, in one case, after the trial was over, the jury foreman went to the judge and complained and said that the police weren't doing their job because they hadn't bothered to dust the lawn for prints. Right?
The lawn?
And so the lawn, I mean the grass, like individual blades of grass, you're supposed to get, fingerprints off of this. Obviously impossible, right? And so that's one of the problems is that people are watching these shows and they're saying, well, I saw it on TV. They must be able to do this in real life, but they don't, right? And so that's one of the problems. The other problem is that when there is, DNA evidence and some of these other evidences present, then jurors tend to give it a little more weight than they probably should, right? They might believe exactly what the expert says, even though we as humans are not infallible, right? We make mistakes. Lab technicians make mistakes. They swap tubes. Things happen. And so we have to always take any evidence with, a grain of salt. Now, the other thing that's interesting about the CSI effect is, surprise, surprise, criminals like to watch television as well. And so it turns out criminals love these types of shows. If you were a criminal, which I know obviously no one is, but why would you watch CSI? Yeah, you get ideas, right? Like, that's how you get away with this, right? And it used to be that, a smart criminal would show up with gloves, right? That was kind of like, that way I don't have to leave fingerprints everywhere. Nowadays, they're not showing up with just gloves, they're showing up with a hairnet, they're showing up with, they're carefully taking all of their bullet casings with them when they leave the scene, because they know that, this is evidence and that this can be used against them. In fact, in one sad case, a serial rapist would force his victims to shower with bleach afterwards, because he knew that it would destroy any biological evidence that was present on them. So, kind of horrible, right? Now, the nice aspect of this is that victims are actually becoming smarter as well. And so, in another serial rape case, the woman was thrown into the trunk of a car, and as she's locked in this trunk, she had the presence of mind to think, I'm going to get away sooner or later, and I need to leave behind evidence. So she pulled hairs out of her head and tucked them all over inside of the trunk. And so that way, when she got away and she went and talked to the police, she said, and in the trunk of this car, you're going to find my hair in these different places. And so they were able to tie it back to it. Right? I don't know if I'd have the presence of mind to think that clearly, but again, it can be useful that if people are watching these CSI shows. She was a big fan of these shows. She knew what the technology could do, so she knew it was important. Now, I teach CSI. I teach, forensics. In fact, we have a new forensics program at the college, which is kind of nice. We train them to go in and work in like a state crime lab or one of these various facilities. And oftentimes my students come in thinking this is what they're going to be doing, right? You get to drive around in a Hummer, you get to wear $900 Gucci heels, life's pretty good, right? In the real world, it's a little more like this. You're going to drive around in a van and wear a polo shirt. Not quite as glamorous. Now, again, it's a great field. In fact, the Bureau of Labor Statistics estimates that over the next decade, forensics jobs should increase by about 27%. That's a pretty decent job market right there. It's still small, but it's growing very, very rapidly. So it's a great field to go into. However, they need to know what they're getting themselves into, right? If they're waiting for their Gucci heels to show up, they're going to be mighty disappointed later on. Why would you wear that to a crime scene anyway? You're going to get blood on it. Yeah. So, let's talk about what some of the other fictions are when it comes to CSI. All right, what's wrong with this photo here? Nothing. That's great. That's television, right? The problem is if this is a CSI, you don't get a badge, right? Turns out the vast majority of CSIs or crime scene investigators are civilians. They're not sworn police officers. And there's a pretty good reason for this, right? One is that they don't need to be. Your job is to show up after the crime is over. You don't need to bother carrying a weapon, right? Because the criminals are already gone. Your job is to come in and do the science. The other reason that many of these, or the vast majority, are not commissioned police officers is simply money, right? If you're a police officer, you've got a decent pension that comes along with that. Being a crime scene investigator doesn't involve the same dangers as being a police officer. So why would they be eligible for the same benefits and so forth? It makes sense. Now, that means, though, that if you want to become a CSI, you shouldn't go into law enforcement. You should go into, get a degree in science, and then you can use that degree in science to actually go and work the science behind the scenes. Now, there are some police officers who do work as evidence technicians. I work with Paul Cavan, who teaches, he's head of the criminal justice program. He spent 26 years in South Detroit being an evidence technician, right? But what that means is that at a crime scene, he would go and he would lift prints or he would swab, blood samples and so forth, but that's it. He would, send those off to the lab. He would never touch it again. So he didn't do any of the science. It was just his job to collect the evidence. Now, this is kind of interesting because we need more people going into sciences, right? And there's a huge demand for these types of jobs. But there are some things that a crime scene investigator is and some things that they're not. One is that the name can change from job to job. So some people in some jurisdictions are called CSIs, crime scene investigators. In Vegas, where the original show was filmed, they're actually known as CSAs, crime scene analysts. I don't know why they changed the name. Some are evidence technicians, some are forensic scientists, some are a host of other names, right? Evidence technicians or forensic technicians, or just lab technicians. So again, I'll just use the term CSI because that's kind of the generic one. Everyone understands what it is. But be aware that depending on if you're state, federal, local, or depending on which state you're in, there'll be different titles for this. Now, one thing that always gets me when I watch these CSI shows is when the CSIs show up at the crime scene, it seems like they own the place, right? They're like, okay, back up everyone, what are you doing? Don't touch that. And it turns out that you're not in charge. Detectives are in charge of the crime scene. They actually go and do the investigating. Your job is to gather evidence and then to analyze that evidence and then send your results to the detectives who can then decide, which suspect to pursue and so forth. That means you don't get to interrogate people. You don't get to chase them down like they do on television. And the shows are getting a little better. They are showing that it's not the same person that does everything. But back when CSI originally aired, it was like someone would show up at the crime scene, they would swab everything, they'd take it back to the lab, they'd analyze it, then they'd say, oh, it's this guy. Then they'd go, harass Bob, and they'd, capture him, they'd, then interrogate him, and it was always the same person. It's not really the same person. You play to your strengths, right? The other thing that always gets me with CSI is when they find a dead body, what do? So they should call the coroner because that's the coroner's job. But oftentimes you'll see that they're going through, the pockets, looking at the ID. They'll roll the body over and, 2 gunshots to the back, right? Turns out that you would be in jail if you touch the body before the coroner releases it. So the police officer that arrives at the scene can check for, signs of life, but then no one else is allowed to touch the body at all until the coroner gives the say-so. And then you can scrape the fingernails, you can take hair samples, you can do all of these different things, but even just going through the victim's wallet would be illegal, before that point. So, a few things that you can and can't do. Now, one of the things that they definitely do, and my computer just locked up, apologize. Let's see what's going on. Oh, there we go. Just a little slow, I guess. So one of the most useful tools that they use is DNA. Why is DNA so important? Why is it so useful?
It's unique.
It's unique, right? Unless what?
Unless it's not.
Unless you have an identical twin.
Yeah.
Anyone have an identical twin? Okay. Well, unfortunately, that means we all have to be careful when we commit crimes. We can't blame it on the evil twin, right? And this is actually an important thing. There was a case in Europe where someone broke into this very expensive jewelry store, stole about $1.4 million worth of jewels, and then they, they left behind some blood. I think they scratched themselves on the glass. So when the police came in and they swabbed it, they tracked the DNA back to this person. Problem is, he had an identical twin, and they both alibied each other. And it was like, oh yeah, he was with me. No, he was with me. It's like, well, one of you or both of you broke in, but because they couldn't arrest both people and charge them both, they couldn't arrest either because they didn't have any other evidence.
Why couldn't they just hold them both until one's untied?
Until one squeals.
Well, yeah, because
Yeah.
can't they just like disable them?
I don't think so. I mean, unless you're going to charge somebody, you can only hold someone so long. Yeah. And so the thing is, they were just waiting to see if one of the twins suddenly became fabulously wealthy, mysteriously, and in which case you know it was that person. But again, it's tricky. Now, DNA, again, is useful because it's unique. It's like our fingerprints, right? The other nice thing is we leave it behind everywhere. I mean, are you leaving behind DNA right here sitting at your table? Yeah. If I wanted to come in and, find someone's DNA, what would I swab in this room? Oh, teacups would be excellent. Because you're touching it to your lips, your epithelial cells from inside your mouth are constantly sloughing off. So you're losing little bits. It seems a little creepy, but like you're leaving behind little bits of you all over. Yeah, the cutlery, good, excellent. So even just touching things, you're leaving behind DNA. Could I swab like the chairs?
Yeah.
Yeah, I mean you're sweating, you're touching things, you pull the chair out. The problem with something like a chair though is if I swabbed it, I would probably find your DNA, but I'd find everybody else's too, right? I'd probably find a dozen different DNA profiles mixed all together, and there's no way for me to separate that unless I actually got the other 12 people and brought them in and got their DNA samples, and then I could kind of subtract it out. Otherwise, it's just a mishmash of everything, and there's nothing I can do. So when collecting DNA, you're always looking for like a nice clean sample. So a bottle of water, right? Typically, people don't pass around their bottle and everyone takes a chug, and so therefore, it's only going to be your DNA on the lip of that bottle. Chewing gum, another example, right? Cigarette butts. In one case, an important case, the suspect broke in, murdered the family and ate their pizza and left behind the crust, right? So he'd been eating the crust and then threw it back in the box. And so they swabbed the crust, and sure enough, there's the DNA, right? So it can be very, very useful, but even though we're leaving it everywhere, everything we touch, you can't always find usable DNA. And that's why only about 10% of criminal cases actually involve usable DNA. DNA is everywhere, but it's just not always in a form that we can actually do something with. The other thing is, on television, do you know how long it takes on average on television to get the results back?
Overnight.
I mean, it's like immediately, right? They've actually had someone sit there and time it. They found the average amount of time was 33 seconds. That's pretty good. Now, obviously, they're cutting to commercial breaks and so forth. They're saying, oh, the next day this happens. But still, they give this false impression that you can get immediate results on everything. And that's just not so. The results will actually take about 20 to 90 days. That's a long time. Oftentimes, that means your suspect's long gone, right? Why would it take this long? Yeah, there's just so much. And every case has probably multiple samples of DNA that they're sending in for analysis. And so right now there's a backlog of over 300,000 DNA samples sitting in labs across the country. In fact, in many cases, if you don't have a suspect in mind, they won't even bother running your sample because it'll go to the back of the line. Because even if you do find, the DNA, unless you have someone to match it up to, it's useless, right? It's like finding a fingerprint, but with no one to compare it to. So why not, bump that to the back? Now, unfortunately, though, there are, several cases in which the DNA is tested 10 or 20 years later, and they find out, oh, the person that we convicted and is sitting in jail is innocent. And then they give them a pat on the back and let them go and say, sorry about that, 20 years, right? And it's kind of sad. So there are a couple of, what was that?
And then they sue.
Oh yeah, exactly. And then they're like, you guys locked me up for 20 years. So there's a couple of projects like Project Innocence, Project Freedom, where they're actually, nonprofits that will pay for these samples to actually get tested. And then they either, help to show that the person in jail really is the correct criminal, or they help to exonerate them. And as part of that, I mean, not only do you not want to lock up an innocent person, but if they're innocent, that means the real criminal is still out there, right? Still murdering or raping or doing all these horrible things. And so it's best to always get the right results. But unless you can somehow rush it through the process, even in those cases, even in a high-profile case where you have a suspect in custody, it's still going to take a couple of days at least to get the DNA results. So let me give you an example of this. Someone want to help me out? Laura. All right. Laura's one of my previous students in chemistry, and she survived, which, that right there, I mean, being my star pupil, that says something. So, she also knows I like to do magic tricks, right?
They're pretty awesome, so pay attention.
I pay her to say stuff like that. All right. So, in this case, I'm going to start flipping through the deck, and you're going to say stop when I do. Stop. There? Yep. Okay. So, I'm going to go ahead and just let you see that. Normally, I'd walk around, but then my students sometimes trip me, and then I feel bad. So, here's my card, right, or your card. We'll say that that's the suspect, okay, or the perpetrator. So I'm going to just put that back into the deck, and now it's pretty well hidden, right?
Yep.
So the idea, though, is that I should be able, if I'm on TV, to just quickly and easily find, not only the name, but, all the information, likes and dislikes, Match.com profile, everything about the suspect right away, right? So luckily, I brought a name tag, right? And so by using the name tag, you should just be able to go like that and change it, so now it says 9 of hearts, right?
Oh.
And then these new name tags are nice because not only do they tell you the suspect's name, but you peel it off and the suspect's actually in there, right? Which is kind of nice. Man, I could get used to applause. I don't normally get that. that, you know, I did all of that, right? It's just quick and it's easy and I get the results right away. In the real world, it's gonna take a lot longer and multiple people will be involved. One person to actually go and collect it, then they send it to the lab. One person does this step, then they pass the rack of tubes to the next person, more assembly line, right? Which, what's the problem with that approach? Yeah, too many cooks in the kitchen, right? Suddenly now you have more chances that someone could lose a tube or swap two of them. Or you're going down the line of like 100 tubes and adding a specific reagent to it, and you get distracted and you miss one. You're not gonna notice, but you're not gonna get good results back, right? So that's why DNA really isn't infallible. It's very, very wonderful and it's very useful, and when it's done right, it's excellent evidence. But it's not always done right. There's always the possibility that as humans we're going to make a mistake. And you swap two tubes, you just swap the wrong person in.
Yeah.
Valerie?
Also, there's problems with people like Annie Dukin at the
Right.
state lab who
Yes.
falsified all this stuff, hundreds
Exactly.
and hundreds of them.
Yeah, so you get a person working at the lab who falsifies results, and suddenly not only are those results in question, but every single case you've ever worked on is now in question. So whether it's falsifying results, falsifying credentials to get the job, right, this is a huge problem. That's why, you know, ethics really is one of those first things. I try to be kind of lenient with my students and try to, you know, if I notice that someone plagiarizes, I'll usually pull them aside and say, hey, you know, you did this, and I'll try to give them another chance. When it comes to forensics, no. I tell them right off on the syllabus, I'm like, you know, ethics is the highest thing, and so if you falsify data, that's not only affecting you, but now the entire state's gonna get sued and so forth. So, you know, your lab notebook, even in a class, is technically a legal document. Everything has to be done in pen. It has to, you know, you have to follow different procedures because, you know, you just make up a number, that causes a lot of problems. Now, the other thing about DNA is once they have it, they upload it to CODIS, right? And it just sits there and it scans through like the photos of all the people, and then suddenly ding, and you have it, and it tells you their address and when they're gonna be home, and you know, all these different things. And then they go and they catch them, right? And that's exactly what it's like though. It's like, oh, nice. They have this little mug shot there. So CODIS is real, Combined DNA Index System. It's a real thing. It's a database maintained by the FBI. And so whenever there is a case where, you know, someone gets arrested, they'll upload their DNA to CODIS. They find a victim, right, unidentified victim. They'll upload their DNA hoping to get a hit, or possibly later, you know, to somehow get a match. If there's a missing person and they have a DNA sample, they'll upload that. Or if they don't have a DNA sample from the missing victim, they will oftentimes ask family members to donate DNA, because your DNA is very similar to that of your family, right? Your children and your siblings. And so that can also be useful. It's not going to be a perfect match, but it'll have some similarities. The rest of the time, your DNA is in the system. So on TV, they make it seem like every single person is in CODIS and you're always going to get a hit, right? In the real world, no. And even when you do get a hit, you're only going to get a few pieces of information. You're going to get the DNA profile itself, right? And the DNA profile is a little bit weird because it turns out that we all share like virtually identical DNA, right? I mean, we all have 10 fingers, 2 eyes, we all have a spleen, right? We all have, you know, the basic same body. And so it makes sense that our DNA has to be almost identical from person to person. Now there is some variation. I have blue eyes. How many people in here have blue eyes? Okay? So that means that, you know, here's a genetic anomaly, a little, you know, change, but even that is relatively common, right? So we can't even go off of that. Instead, what they'll do is they look for these things called STR, short tandem repeats, and it's basically like nonsense DNA. It's like the static on your television set. So in between the important genes that code for all of the stuff that makes us us, there are also these random little nonsense bits called STRs. And so you can look at that, and that region is hypervariable. It'll change from person to person. So we can look at that and say, you know what, only 1 in 10,000 people happens to have this little bit of nonsense DNA. And then they'll look at a different region and they'll say, oh, only 1 in 500, oh, 1 in 3,000. And so the odds of someone having all of those exact same sequences is, this times this times this, and that's where they get those astronomical numbers of, there's a 1 in 8 trillion chance that this is just a random match between DNA. So, that profile, those short tandem repeats, are stored on CODIS. So you get a hit and it matches those up. Then it tells you, oh, the San Diego Police Department uploaded this, this DNA profile. They tell you who it was at the San Diego Police Department who uploaded it, and they tell you the tube number. Oh, this was B307. That's it. Notice that you don't get the suspect's name, you don't get their address, you don't get their, photo, you get nothing. So how do you actually get all that information? Yeah, now you fill out the paperwork, now you contact San Diego, right? You ask them to send you the file that's associated with this tube number, and then after a week or two, and then you send it again, and then you finally get it back, and now you actually have the information that you can go and try to track down your suspect. It's difficult, right? Not quite as easy as they make it out to be. The other problem is the software doesn't always talk nicely from place to place, from state to state. So sometimes you just get mismatches, you get problems like that. So again, this is a real, database, but it's not quite as useful as they make it out to seem. Some countries in Europe are actually causing everyone who gets an ID card, basically like a driver's license, has to submit DNA and fingerprints. It's kind of an interesting idea that your DNA and your fingerprints would be on file at some national database, and then anytime someone commits a crime, they just scan through and everyone would be in there. Now, they'll never do that here.
They can't because it's an invasion of privacy.
Exactly. So that's the thing, is here it'll never happen. But there are definitely, pros and cons to each thing. It would be nice from the law enforcement side because you could easily solve any crime, right? But the idea of having your DNA and your fingerprints somewhere seems a little scary, right? So, yeah, kind of an interesting idea. The next thing I really like on CSI is that magic enhance button. Have you ever seen this before? So, here are some images from one of these shows. What they'll do is they'll sit in this dark room, because it has to be dark, with ominous music playing. That's usually the best way to do your work. And they'll have some grainy security footage. Like, okay, this was taken from the garage across the street. As you can see, here's our suspect. And they'll say, wait a minute, on his sunglasses there seems to be some kind of reflection. They'll say, can you zoom in on that? They'll zoom in and they'll get this, and they'll say, zoom in a little bit further. They'll get this, and then they'll say, can you clean that up a bit? And they'll say, enhance. And they push this magic button, and suddenly, they'll be like, actually, this is the reflection of a patch on someone's uniform that was standing next to our suspect, and then that cracks the case, and then everyone goes home happy, right? Now, I've looked all over. I mean, I have a Chromebook, and I've looked everywhere. There's no enhance button on there. I don't know. Maybe the newest ones have it, but yeah, it turns out that this is completely impossible, right? If you're into digital photography, you'll know that each of those little squares represents a pixel, right? And that pixel stores the information. What's in between the pixels? Nothing. I mean, there's no information stored in between the pixels. It's like saying, what's stored in between the pages of a library book? Like, air? I don't know. Like, there's nothing there. There's no information in between the pages. It's just what's on the pages that matters. And so there's no way for a computer to go in and just, make up what's in between it. Now, there are some programs that they're testing out that can possibly interpolate the data and try to kind of guess at what it is based on the neighboring pixels and so forth. Still all experimental, but can you imagine trying to explain that to like a jury? So can you explain to the jury exactly what the computer did? Well, it takes the information and then it kind of makes up what's in between. It doesn't fly, right? So, unfortunately, you can't do this. Now, what can you do? Really, you can do the same thing that anyone with Photoshop can do. You can adjust the contrast, right? So you have a photo that's a little underexposed on one side. You can adjust the contrast. Now you can see a little bit better, but now you've overexposed the other side. So you can alter things. You can zoom in a bit, but at some point, when it gets to like a grainy, blurry image, there's nothing you can do. So, no enhance button. Now the next thing, oh, back up 1 second.
In the dark.
Personal protective equipment, right? PPE. So Laura will tell you, I'm a stickler for wearing your goggles in the lab, right? You kind of have to. Why? Yeah, you have to protect yourself, especially if you're working with, you know, like an autopsy or something, you got to protect the evidence as well. I mean, this is what they show on CSI. They're all kind of standing around, they're going to do this autopsy, they're eating their donuts, you know, they're just sitting there. Little hair falls off of Gil Grissom's head and lands on the victim, and they're like, wait a minute, this must be from our perpetrator. And they're like, oh wait, that's mine. They put it back on, right? So, you have to protect the evidence from you. You don't want to possibly contaminate it and make it look like you're the suspect, right? But probably more importantly, you have to protect yourself. I mean, you're going to be doing an autopsy. You're cutting into this thing. There's, you know, fluids. Yeah, exactly. I mean, they don't even wear goggles or gloves or anything. So imagine if this person had hepatitis or HIV, Ebola, who knows, right? So, yeah, you're just contaminating yourself. Now you have HIV or hepatitis or whatever. So, in the real world, I've never had to do an autopsy. I'm not a medical doctor. My wife likes to say that I'm a doctor, but not the kind that helps people. So I know it's a little bit. I worked hard on that piece.
Sad.
So it turns out I've actually seen an autopsy performed, and this is a little more what it's like, right? Full protection, because you know they've got the gloves, they've got the bodysuit, they've got the mask, the goggles, the hairnet, and then they have the face shield over the top of that. Now, I can imagine that on TV they don't want to do this because it's not quite as dramatic, right? They can't zoom in on Gil Grissom as the bead of sweat drips down his forehead as he's trying to figure this out. Plus, imagine, like, you know, they'd be like, a little muffled, not quite as intriguing and glamorous, I guess. Now, next thing is, obviously, as I mentioned, you have to work in the dark. It's pretty much a requirement if you're a CSI, right? They're always running around, and they have their gun and they have their flashlight.
Yeah.
I was going like this everywhere, and I just think, just turn on the lights. Seriously, I mean, did you not pay the power bill? Like, what's going on here? It's ridiculous. Why would you want the lights on? Yeah, so you can see what you're doing, right? Imagine missing like a little tiny glass fragment that's in the carpet because you just couldn't see it and you're stepping on things. So even in an outdoor crime scene at night, they're going to bring in big old spotlights, they're going to shine it everywhere because you have to be able to see. Now the only time, I mean this is, you know, again, you're like, oh here, I've got a flashlight, that should be good enough, I can see what's going on. Now, in the real world, the only time that you typically work in the dark is if you're working with a chemical like luminol, or blue star. So this is one of the few things that's actually realistic that's on TV. So my students love this, it's like their favorite lab, is there's a chemical called luminol that reacts with the iron in your hemoglobin, in your blood, and it causes this luminol to glow. And so you'll have this, you know, this crime scene, and you don't really see any blood stains because maybe they tried to rinse it off or, you know, whatever. You spray it, and suddenly you get this nice blue color, and it glows. And it's actually kind of sad that it's such a lovely blue, luminous glow when it's blood, right? But that's what it looks like. And this is extremely powerful. If you take 1 drop of blood and mix it with about 100,000 drops of water, luminol will still pick it up. That's pretty good, right? So even if, you know, like you tried to spray it off really quick, it also works for years and years. I had one of my students, when we did this lab, she brought in an old pair of khakis that she had gotten a little paper cut and had gotten a little tiny smudge, like near her pocket. She had washed these things multiple times over the years, right? And she brought them in. We sprayed it with luminol. Sure enough, still glows. After 5 years and multiple washings.
Oh, wow.
If there's any of the iron that is stuck to the garment itself, it's going to continue to, you know, fluoresce. Just pretty impressive. So this is nice. The other nice thing about luminol is, you know, I mentioned earlier that sometimes people will say, oh, I know I've left behind biological evidence. I'm going to use some bleach because I know that'll destroy the DNA and so forth. Turns out that bleach actually glows even brighter with luminol. than blood does. And so you go in and you spray this, you'd say, someone tried to bleach this area. Now, is that evidence that they murdered someone? No. Could be they dropped a chicken breast on the ground when it was raw and they decided to try to clean it up, right? But this tells you should probably investigate a little further. And so you go in, you swab the grout lines, you swab the cupboards and so forth, because if someone's been murdered, that blood gets everywhere. I do this one lab with my students, and I don't like cleaning it up, and so I put paper, like wrapping paper, all over the walls, and then we had a little pool of imitation blood and a lacrosse stick, and I'm like, okay, don't hit it too hard, right? Just hit it from like 6 inches above. Even from only 6 inches above, we were finding little blood droplets like 20 feet away. And some of these are extremely tiny, so they're everywhere. Yeah, it splatters everywhere. So in this case, even though they tried to quickly clean it up, chances are they've missed some, right? You're still going to be able to find that. Another example was I have 3 little kids, and my youngest daughter she was pet sitting this chinchilla. I don't know, chinchillas can be mean, right? This one was named Old Man Jones. He was cranky. And so she's sitting there holding it. She gets bitten, right? It was a pretty good chunk out of her. But so she freaks out, and she starts running up the stairs screaming and going, ah! Little blood droplets everywhere, right? And I'm sitting there like, I gotta get my camera. This is great, right? You will not go and show blood spatter photos from our daughter's chinchilla bite. But it's so useful.
Scientist for you.
So it turns out that, this, again, there are some realistic things. Some things are a little fake, right? So one example of something that's completely fabricated, if you like bones, this, right? They have this 3D hologram, they can show bullet trajectories, completely fake, right? Nothing like this in the real world, especially in like a government-funded lab. That's not gonna happen. So, even though it looks nice, this is a little more what a real lab would look like. Notice they paid the power bill, so the lights are on. That's kind of nice. People are wearing gloves. If they're using tubes of open DNA, they're going to be wearing a face mask so they don't breathe on it. It's nice and sterile and clean and organized. It's a little more what the real world would look like, right? So, I brought in some evidence here, and I'm going to quiz you and see what we could figure out based on these pieces of evidence. So, I'm going to go ahead and turn this off and turn the lights on.
You hope they hated you.
Yeah, exactly. Just hidden back here. All right. So, a couple of different pieces of evidence. So one, here is a can for arson evidence. So why would I carefully package like I don't know, some rags that I found at this arson case? Why would I put them in this paint can?
Find out what the accelerant was.
Good. You're looking for the accelerant. And it turns out that it's the fumes that actually burn, right? The liquid itself isn't flammable. I mean, gasoline, liquid gasoline, won't burn. It's only until you spray it and diffuse it into a gas form that you can actually ignite it. And so if I collected a piece of a rag that was soaked with alcohol or turpentine or something, and I don't bother to cap this off, all the fumes are going to escape. And eventually it's just going to be a dry rag, and now I've lost all the evidence. So instead you package it in one of these cans, you tap it down, and then there's this little rubber septum here. So you can take a needle, a syringe, puncture this, draw out some of the vapor, some of the gas above it, pull it out. This automatically seals itself, and now you inject that into a gas chromatograph, and it'll actually tell you what the accelerant was. I've done this with my students, and they love it. I mean, this is pretty cool. I like it too because I get to burn stuff, and so I'll go and like burn things using gasoline. I won't tell them what it is, and then their job is to figure out, what was used to burn down this little wood chip. All right, so that's useful. What about? Ooh, I've got some insects here. Kind of hard to see, but here are some fly eggs. Here's the maggot, the larva, and the adult male and female. Why might insects be useful at a crime scene?
Time.
Seeing how old.
Good, yeah. So like the time of death, how long the person's been, laying out in the woods, because flies and other insects have a very definite life cycle. And so they, depending on the temperature and the weather and so forth, you can look and say, this maggot right here, that's, 8 days old. This person must have been at least, dead for 8 days. Because flies won't, at least here in the US, luckily, thanks to DDT, we killed off all the different flies and things that, like screwworm flies, had those up until the 50s down in Texas, where they would lay their eggs on like living things, but flies here don't, right? So, so that means that, they only lay their eggs on decomposing matter, and then you can look at the life cycle. So pretty useful. Turns out there are a few other things that are useful about our good friends, the flies. One is that you can, even if the body has decomposed completely, you can actually look at the larvae themselves and sometimes get toxicology results from the maggots. Right? So if the person was poisoned with arsenic, you can draw that out of the maggots. It turns out that maggots grow more slowly with arsenic. For some reason they don't like it. I don't know. But turns out that maggots love cocaine. So I always tell people, don't do drugs because maggots will love you. It's scary. They should put that on like a public service announcement. Instead of like just all the other ones, don't do drugs. They could be like, you will be maggot fodder, right? So, yeah, it can hurt, right? So you have some squirming maggots. So yeah, it turns out that maggots eating, a body that they've used cocaine will actually grow faster. You can sometimes actually extract cocaine from the maggots themselves. Pretty gross, but useful. Also, certain species of flies only live in the city, some live only in the countryside. So you find a body out in the woods, out in the country, and it happens to have species of flies from both the country and the city. Probably means someone must have moved the corpse, right? Exactly. So that can help you to kind of recreate the crime scene. So some useful things, even though it's kind of gross. I do a lab on forensic entomology, but I use pipe cleaners. They're cut up into different lengths. Not quite as creepy as actually bringing in maggots and having them measure it and so forth. I don't want to clean up the vomit at that point. So, all right, what about you find a skull in your backyard? Hopefully not. But what could you tell about the individual based on just the skull? Okay, approximate age, right? So it turns out that as we get older, our bones start to deteriorate, so especially around the jaw, we could look at that. If it's a really young person, we could actually look at the skull plates and see if they've completely, hardened up. What else? The teeth. Teeth are extremely valuable, right? This one, you can actually open it up and you can see they've got an impacted wisdom tooth there. That's going to be expensive, right? My 2 girls are in braces right now. I'm just like, I should have been an orthodontist. So you can actually, in this case, pull some of them out. Even a single tooth, drilling into it, you can actually find DNA in the tooth hole, right? And teeth are the hardest part of the body, so even after everything else is decayed, you'll still find teeth, right? So that can be very useful, especially if it's like you can match it up to a missing victim, missing person cases, right? Because you can go back and look at dental records. It's one of the few x-rays that we get regularly, right? So pretty much everyone has dental x-rays somewhere that could be useful. What else could we determine about the victim?
Male or female?
Male or female, good. So again, not perfectly, unless we do DNA testing, but the size of the skull, men typically have a larger skull than females. The brow ridge is typically more pronounced in males than in females. Again, you'll always find exceptions, but it's a quick and easy way to be like, you know what, we're probably looking for a male about age 50, who has really bad teeth, right? And so that can help. Race as well, like ethnicity. Again, not perfectly, but there are different features. The cheekbones, the shape of the eye sockets and so forth.
I was just going to say the eye socket.
Yeah. And again, especially if someone of like mixed descent, you're not going to be able to know exactly, but you can typically narrow it down to, one of the categories, right? So again, useful just by quickly looking at the skull itself. All right. What about these? So arm bones. This one's plastic. I stole this one from the anatomy lab. This one's an actual human bone. Don't ask me where I got. No, I'm just kidding. I borrowed this one from the anatomy lab. One tip is when you're traveling around with human bones in the back, don't get pulled over, right? Because then you have some explaining to do. That's for science, I promise. So, this is the radius, and this is the ulna. That would be these 2 arm bones right here, right? So the ulna going from your elbow up to that little nub right there on your wrist. So that would be this bone right here. So if, let's say, I own a junkyard and I go and I find this bone in the junkyard, what can I tell about the person?
There's a woman.
Okay, definitely small, right? And they're missing an arm. But, but yeah, they're definitely, look at that. That's a good, about 2 inches shorter than my ulna, which means they're probably a good 6 to 8 inches shorter than I am, right? So, again, not perfectly, but there's a formula that the FBI uses where they can look at one long bone, like a femur or an ulna. They can calculate approximately how tall the person is. I do this with my students where I have them measure their own ulnas and then measure their own heights and see how accurate the prediction is. And it turns out that I'd say 95% of the time it's within about, 2 inches, which is pretty good. Again, not perfect. You won't be able to say, oh, you know what? 5, 10, and 3/4. But you can say we're looking for, based on this and this, we're looking for, a Caucasian female, probably age, 35 to 40, who is, maybe 5'6" to 5'10". That's pretty good. You've now narrowed it down quite a bit and can look at just those cases, right? So it does help to speed things up. Again, DNA would be perfect, but DNA takes time. And especially in a case where the bones have been left to weather out in the environment and so forth, we may have too much, degradation and so forth that we can't actually test the DNA. All right, so that is all I have. I'd be happy to answer some questions. Thank you so much for your time.
Is there any way that they can speed up the process of DNA? Is anybody like inventing, thinking, doing?
Yeah, there are some high-speed DNA sequencers where they're literally trying to sequence like the entire genome. And so they actually will shoot the long strands of DNA through this little micropore and then look at the electrical current as each of the DNA bases travels through it. So there are some really sophisticated techniques, but right now they're all kind of,
In the process.
in the process. They're expensive, but we are getting better. Back in the OJ case, which was the first big case that caused people to know about DNA, we were using a different type of DNA, which wasn't as accurate. They were looking at these restriction length, fragment length polymorphisms. You needed much more DNA. Now you only need a few cells worth of DNA to do the STR, and it's more accurate. So we are slowly making progress, and eventually I think we'll get something where you put it in a machine and it'll be a little more like TV, a couple hours later suddenly you got the DNA.
Well,
But
what about that famous glove that he said was not his?
the bloody glove, yeah.
Wouldn't there be DNA inside?
Right. Yep. So, yeah, there should be DNA from sloughing off the skin. I believe it actually had blood inside as well from where he cut himself. Couple problems with that. One is that when they collected the glove, they stored it improperly. So imagine having a glove that's wet with blood, a leather glove. What happens if you don't dry it properly? It shrinks, right? So what they did is they threw it in a Ziploc bag in the back of a patrol car for a couple days in this California heat, right? Suddenly it's shrunk, and
He said it wouldn't fit.
yeah, exactly. The glove don't fit, you must have quit, right? Is that what they said? Johnny Cochran. And so the problem is, yeah, they go and they have him try it on, and he's like, oh yeah, it doesn't fit. Later on in the case, they brought in the exact same type of glove, right, same size and everything, but a brand new one fit just fine. No one remembers that, right? They only remember him trying to put on the bloody one. The other problem is because they stored it in a Ziploc bag, we all know, my kids come home from swimming, if we don't wash their clothes immediately, if they just wad them up and throw them in the back of their closet, what happens? They start to smell, you start to get mildew and mold growth, and that's exactly what happens with a wet glove. If it's stored in an airtight Ziploc bag, mold and mildew start to grow, and mold has DNA as well. And so now suddenly the DNA in and on the glove is now contaminated with all this other DNA. There's no easy way to separate that out. And even if you can separate it out, it now brings in doubt into the case, why didn't you store this properly? What they should have done, and what proper policy is you'd collect the glove, and then you would dry it out, or worst case scenario, if you had to transport it immediately, you put it in a paper bag, which is breathable, and that way it would help to dry it out.
What you see now is
Exactly, and they tape it up and everything, take it to the lab, and then they'll dry it out there. So that's what they should have done. The other big problem with that case is that they didn't follow proper chain of custody on pretty much anything, right? When you collect something, you have to write what it is, where you found it, date, time, everything, what your name is. Then when you hand it off to someone at the lab, they sign for it and everything. That way if something goes missing or something gets damaged, you can kind of track it back. So one of the key pieces of evidence was they took some of OJ's blood for a DNA comparison. But they didn't bother to write down exactly how much blood they took. And so later on when they questioned the woman on the stand, she's like, yeah, I think I took like, I don't know, maybe 10 or 11 milliliters of blood. And then they said, look, the tube only has 7 milliliters of blood in it, which means that they must have taken 3 milliliters out and used that to plant evidence at the crime scene, right? The other problem was when they collected the blood, the detective just like put it in the bag, stuck it in his pocket, and carried it around for like 3 days before turning it into the lab, right? So again, now there's doubt that not only do we maybe have a couple of milliliters of blood missing, but you know, it's also, they had the perfect chance that they could have planted it, right? And so that's the thing, is like, they didn't find him innocent, right? They found him not guilty because of reasonable doubt. And again, there's a lot of argument about whether there still was reasonable doubt and so forth, but that was one of the main cases that kind of showed people, hey, you really have to be careful with this. The other problem was, I mean, it's a high profile case. People would go in and like take photographs, you know, souvenirs, things like that. People were walking in and out of the crime scene. Even when they found Nicole's body, one of the officers grabbed a blanket off of the couch and covered the body with it, right? And now, you've now contaminated the entire body, right? So now if you find OJ's DNA on the body, he can say, well, I used to live there. I snuggled in that blanket every day when I was, you know, reading, and now my DNA transferred from there onto, you know, the body, and it's true, it could be possible, right? So now a lot of people blame the police department, and they should shoulder a lot of the blame, but at the same time, imagine having like a camera on you 24/7. You're bound to make mistakes too, right? And it's just, our mistakes aren't often publicized, luckily. And so, it's like when I'm in class, I'll make mistakes all the time. Usually, people don't pay attention, so they're just on their phones, and I can play it off as like, oh, I meant to do that. I was just testing you to see if you're paying attention. Yeah. So, whereas in the real world, they would be like, wait, you messed up this. Obviously, you don't know how to do chemistry. You don't know how to do forensic science. You're an imposter. And then, yeah, you're ripped apart. Other questions? Yes?
Does DNA ever degrade?
Under ideal circumstances, no, but in the real world, yes. So you can have a sample of DNA, like the bloody glove, if it was properly stored. You could keep that pretty much indefinitely if it wasn't contaminated by other things. You can also take it and you could freeze the sample in liquid nitrogen, and that'll preserve it forever. But in the real world, exposed to the elements, no, it's not going to last very long at all. Simply because we would be overwhelmed by DNA. Our bodies actually produce, you know, proteases and so forth, enzymes that'll help to break things down, because we don't want all this random foreign DNA. So, yeah.
So if they found something in a cave, say for quite a long time, would that be preserved because it's been in a cave? Or
Depends on like if it was dry enough. Like for instance, the you know, they can do DNA on mummies in Egypt, right? Simply because those were like ideal circumstances. You have this nice, hot, dry environment, everything dries out, and then it's perfect. A wet cave, probably not. You're probably going to get, you know, contamination, mold growth, all kinds of things. But again, it depends. Any other questions? All right. Oh, yes.
Do identical twins have the same fingerprinting?
No, not the same fingerprints.
Okay.
Yeah. So it turns out that even if they do have the same DNA, but not the same fingerprints. So yeah, I mean, no one has ever found like 2 fingerprints, even like 2 fingers on the same person that exactly match up. Now you can get partial prints that match up, right? And that's where the expert has to come in and say, oh, here's this smudged partial print. How much of a certainty do I know that this is a match to this, you know, clean print that we got when we, you know, arrested the person? And that's where it's a judgment call. Like, oh, it looks pretty much the same. If there's anything that's different, you can obviously exclude the person, but you're gonna have similar partial prints to people. And especially if a criminal's, you know, touching things and they just smudge things, it's gonna be difficult to know exactly. All right, well, thank you so much. I'll stick around for a few minutes.